Hello, I'm Bela, the developer guy, and welcome to my channel. I will do a real-time soldering video this time. This will be a soldering tutorial too, and a demonstration for the STM32 Arduino. Thanks for tuning in, and well, let's start with soldering. And what's the STM32 Arduino first? Well, when Arduino launched the Arduino Uno R4 and changed the 8-bit microprocessor to the 32-bit one, then I thought it would be fun to make another Uno with a completely different microcontroller, but that's not really the point. It was a really fun project to get to this point and have a own microcontroller board. The reason is that I would like to have a own board where I can teach you how to use STM32s and how, well, if you check out and you have worked only with not native ones, but with Arduino, then well, it's probably just hard to switch to a professional environment, but yeah, that happens, and I would like to show you guys it's not that hard, and I would like to make a course, conversion therapy, where you can switch to native embedded development instead of using Arduino. But first switch to the PCBs and the PCB design and all the related stuff. Well, if we get a brand new PCB, how do we kickstart it? So you can already see that I have several different versions of, well, it's the new version. So these are the old revisions of the board. You don't just assemble it first, everything, but you can start with easier parts, or yes, first you have to assemble. In this case, the power circuit, it has a dual power just like every Arduino. You can power it from the USB port or from a parallel jack, and if that works, then we can go further and, for example, install or solder in the USB UART IC and things like that. So and after the basics work, then we can switch to the whole circuit, and we will just do that this time. But first, thanks for PCBWay for sponsoring this video. Well, they made a pretty good job, so the PCB turned out really great, so I'm really thankful for them for this. But yeah, I've tested it before, so I'm really confident that this will work. So, and also I prepared all the components here on my desk. So I have the normal components, capacitors, and everything prepared. That takes a lot of time, so I did it off camera. But first, we can either use hand soldering. I prefer these syringes, and they come with different size needles. You can change them. I like the smaller ones because yeah, the bigger ones can dispense more goo, but for smaller footprints like here, I think it's better to have less solder, because they tend to goop up, so we have to prevent that. So let's start with all the little goops, balls of solder. So when you have smaller components like 06, 03 or 04, 02, then these bigger ones just give us too much, and it can be handled easily. And yeah, we start with resistors and capacitors and all the small passives because they are the smallest parts. And of course, if we have taller components, then we have to navigate between them. So it's easier to build from the shortest and go later on for the more taller components. Light squeeze. Last time I gave too much solder here for the diodes. And this may take a bit too much time, but feel free to ask in the chat. So it seems we have all the resistors and capacitors. And I usually just apply solder paste everywhere. Okay. Here the USB-C connector has yeah, really tiny pads, so we will apply some extra flux there, and for extra mechanical stability we add some solder here. And the small nozzle really shines here with these smaller footprints, otherwise it would be just one big mess. The videos where you see that they just spam a lot of solder paste and hot air just works, it's true, it's not a lie, but no wonder why people use stencils and use masks for applying paste. And almost forgot the LED. And let's have some here for the microcontroller too. There you go. It seems everything except the reset button, because I have the wrong size, so I'm not installing it this time. Then we switch to the flux. Add some here too. Maybe a bit too much, but you can see that these big nozzles just dispense a lot of paste. And it seems fine for me. This didn't take too much time, but the time-consuming part comes now. So I go now from the biggest capacitance to the smallest. So now we apply 22 microfarad capacitors, and let's just put them here on the right side. These aren't the smallest components in the world, but they can fly really far if you just wiggle the tape. And I have the parts and the legend and designator places open in another window, so I just know that we go here to capacitor number 10, gentle tap, because otherwise it may walk away, and capacitor 9. And sorry for the fan, for the power supply of the LEDs. But in the meantime, anyone who says hot air doesn't blow away parts, you just didn't. So the solder paste just fixes them. That's a big fat lie. So hot air can and will blow away these little parts. So now 10 microfarad. We only have one here. And by the way, we are assembling only one here at the time. We see that a lot of time is wasted between switching components, so it's really recommended to solder things in bulk. For example, solder all the 5 boards at a time, and just place all the 10 microfarad capacitors at a time, and so on. But that's life. We have 1 microfarad capacitors. Well, this is a bit off. I accidentally used 0806 sized ones. No, 0805, sorry. And this goes to C3. Okay. We have regular 1 microfarads. It says we have at least 4 of them. And they go to C2. As you can see, the big barrel jack will come here, and this part is the main power filter, because we need some buffering and filtering here too. We will need some for C4, if I can find it. Here. And one thing, tweezers can get a bit of solder paste on them and they get sticky. So it's not magnetic, it's the residual goo and stuff on these capacitors. So sometimes you just have to handle them like this. C11 here at the USB UART part, and one for the microcontroller. We will use a 1 microfarad 100 nanofarad filtering here, but we will need bigger values at the power supply. That's normal. And finally, no, this that 10 micros. Always check what parts you get. and 3 decoupling capacitors. As I said, one for the power supply of the microcontroller, one goes to C8 because the power supply actually needs it for feedback in series, not in parallel, so it's not filtering, but it's high frequency pass-through stuff. And C5, one for good measure at our little friend here. Okay, capacitors are done. It seems we finished all the capacitors. Now we can switch to resistors, and since I have small desk space, I have to switch the parts. So we continue with the highest resistors. We have a 56K one and 10K in series to make the feedback voltage for our power supply. And I like to add personal touch by having a reading direction and make all the passives readable from one direction if possible. We have one 10K. If you are serious in your hobby, buy in reels. For example, the more common 10K or 1K resistors, it's not that expensive and you will need them a lot. Now I also buy LEDs in reels, so I always know I have some spare in the garage. We have the magical 5100 ohms or 5K ones. These are for USB-C compliance. You pull down the CC1 and CC2 pins, if I remember correctly, to ground with these. It will tell the power supply or the other side that yes, I'm sync, I want power, and I think this 5.1K tells that I want the maximum 3 amps, if I remember correctly. Now we have a minimal but compliant USB-C connector. We move on about 4.7K. Just because the external power line can operate from 12 volts, we will have a bit more beefier resistor here. And just tested, all the other ones are fine with 1K. So the pin 13's LED and all the other 3 ones are fine. Thanks, Robocolond. Any questions or what are you curious about the process? So 1, 4. Alright. LED here, one for this power line. By the way, these LEDs were suggested on Twitter, so if you have ideas and stuff like that, I'm happy to hear them always, because this is actually a good idea, because you can have an indicator that the power line is okay or not. And while debugging, I fried one of the power ICs, and yeah, it showed that you don't have power. So some power LEDs are okay, but not the blue ones. You won't see any blue status LEDs here. Blue is for either Bluetooth, or if I have a espresso milk frother or something like that. I don't know what it's called. And when you just want cold milk, then that's where the blue LED is acceptable, otherwise not at all. Okay, they are just too bright and they're just annoying. So I think we are finished with resistors. It's not a too complex PCB, but still, always double check if you finished. I almost missed here. Now let's get the LEDs. I decided to go with red for USB power and external power, but of course you can use almost any type of LED. And I just got 3 of them, so that's life. I just can't put back you. Sorry, little guy. I have some spare orange ones, or amber to be precise, and I just dipped it in flux. By the way, there's a cool little project, the bean counter, which uses these little holes, and you just pull the bean counter on it and it will say that how many components you have. If you don't just use 1 or 2, it can be handy. And just for a little comparison, this LED, if it comes off, is ruled in 2 ways. Once, it doesn't want to come off from the tweezers, like this. Secondly, this other one has a little green arrow on the bottom here, just here, if you can see it. And it's a bit green here, but this LED has no marking on them, but really pros can see that where the chip is located. So if I'm not mistaken, this is the direction where the amber LED goes. What microcontroller? Hi Imad, just bringing in here. This has the STM32C0. These are relative new ones. They are dirt cheap. That's why I chose this for my project. I want to make it as cheap as possible. But of course the new ones will have the bigger microcontrollers too, because Well, we have a lot of pin duplications, as you can see here in the labels, so that's a bit bummer. So we left that the green LED. Yes, test an LED before soldering it. That's a good idea. Thanks, Imad. If you use a multimeter, you can have the diode test mode, and LEDs will just turn on and have a faint little light telling if it's the correct orientation or not. And we will have white LEDs for this LED, and if you are using the correct symbols, you can see the little triangle. It's not too easy to see. Now this rather PCB. These little triangles show that this is the direction, while diodes can have those little other marks, or in this case this diode is easy because you can see in the bottom it's not symmetrical the way we would like to see, and there you go. A white little LED. I think we finished with the optical stuff. And yeah, while we were at the diodes, diodes are polarized also, just like LEDs, and they have a little marking here, a little line. If you can see that, it indicates how to position them if it doesn't have pads like this. Boop. It took some time to prepare all the new components here, so that's why it will be faster. I even oriented them so the show isn't that boring. Well, start with the shorter one, the fuse. This is a polyfuse or multifuse if you haven't heard about it. Or resettable fuse. If the short circuit is removed, it will repair itself in some time. So it's easier to work like this, and I just turn it for the microcontroller because it's easier to grab than like this. The reason why I use this so much flux here because this footprint is notorious for having little globes. And the final SMD part what we have today is this USB-C connector. And now we will switch to a quick rearrangement so you can see stuff getting soldered. Please be patient for a second because I have to remove a lot of stuff from my desk. And you see that. Just a moment. And not the best angle. But we will be able to see some of the soldering action. I have my webcam here too, but doesn't give us too much light, so I hope it's enough for you. So, this is my cheapo soldering station. It means it was made from, not from much, but I really like it. I have a big oven, and I just have a free flow station, hot air, and classic soldering gun, but I'm experimenting with this. So I'll push the button together, and in mere minutes we can see the magic, but in close-up. After that we will probably need some touch-up too, but you can already see here that the flux is already melting. Heat profile on this, no, it's just a regular PTC heating plate. It means it goes in theory up to 260 degrees Celsius in 2 to 3 minutes. So it's really crude, but I had some results with it. Yeah, with regular, professional and more expensive hot plates you can have some better profiles, but this is the fun. So we already have some smoke. And soon it will be finished. By the way, this hot plate method is only good for one-sided PCBs. Oh, and We already have some magic here. Yeah, because it's in the middle of the heating element, of course, and we can see that other parts are not ready yet. Not even the... Oh, well, the LEDs are getting cooked in the middle. Just fine. It seems like the USB connector is also fine. Just checking it with my eyes here, that it seems everyone's ready. Even R4 too. And if it seems ready, then we just turn this bad boy off. And because I have gloves on, I can do this. Oh, well, I have tweezers. Take it off. And we will check out the results in a few seconds. I will just switch back to the old view. Rearranging the desk again, and I will try not to step on this 200-degree plate. Do I check the temperature? That's a good question. No, I manually checked it with an infrared thermometer once and hope for the best. This is really the cheapo version, so yes, I could buy, or even I have a big reflow oven in the basement, but this is just for fun to try this out. And yeah, after soldering, and you hear the clank, that was when it fell on the ground, but it survived seemingly. What problems we can have after soldering? It seems we have some solder balls, tiny ones, but that's not a big problem here. Yeah, let's just dive in. And that's the maximum zoom, so we have to go back a little. So USB-C connector seems fine. It's fine pitched, but I've seen worse before, and because I didn't apply too much solder paste, we have one little ball here, if you can see, but it made a short. We will have to revert that. Others seem fine. Diode's fine. And last but not least, the microcontroller pins. It looks weird, so we will touch that, but the other side seems fine. Yeah, I hoped for some errors, so I can show off my mad rework skills and show you some tips how to do this. Luckily, these pins are accessible here, unlike some SSD pins I encountered. My friend gave me a portable SSD, and the pins are way back in the behind, so you can't see them. But Now, how do we remove these little balls of love? Well, first of all, I would have been wiser to move this resistor a bit further back so I could touch up all on these easy, but that's for future designs. So, anytime you have shorts, first get some flux there. It won't resolve the problem by itself, but it will help mitigate. It will increase surface tension, so anytime you touch up with a soldering iron, it will help move the excess away. Well, I will artificially introduce some shorts here to show how to remove them. It's much easier to do it here. But if you have a dirty head or end, that's not a good thing. Just scrub it down, and hopefully it seems like hot. How do you check if it's hot? Yeah, apply some solder. But we have some excess solder here, so that's enough. And just gently wipe. And in this case, it seems it was enough, because it wasn't too much. So some excess solder gets on the tip, and if you wipe, the excess solder gets everywhere else, so it will be better. What we didn't check if these got soldered, but I really hope they got soldered. So yeah, they soldered. You can't remove it by hand, so the shielding is also a mechanical stabilizer here. But yeah, let's mess up things either to show or to fix this problem. So some problem happened during soldering. We applied too much paste, and by too much I mean too much, and we have to apply a lot more. And finally, we ended up some shorts. So if you have a lot of solder on the tip, you will just move the blob. That's no good. So clean the tip, remove all excess solder first, apply some flux. We already have some here extra. You can see that it's like it peed itself. That's some excess flux that should be removed. There are no clean fluxes too, but this one is just a regular one. So, and it's already expired, but yeah, whatever. You gently tap and wipe from one direction to another. Scrub away excess. Wipe, scrub, and if it's really excessive, then you can get these copper braids or what, and copper loves solder. You can push it there, apply some extra heat, and if you are lucky, you can see the solder getting sucked into. Well, it wasn't so spectacular here, but it seems it's fine. So we did some rework too. That's great news. But before we kill our computer, let's plug it into an external USB port, either a USB hub or a charger, and see if the power is okay. And yes, USB power is okay. External power is not okay because we don't have external power. The 5-volt line is working and the 3.3-volt line is working to regulate everything just fine. Yes, the LED is bright because it's in its reset state, but that's life. So let's solder the remaining components. It won't be that hard. One power connector and one for the debug. I usually get a breadboard, just plug the pins there and it's done, but now I hope it's fine and it looks okay. But what if it's not so easy to install these, and what if I lose the connector? There's a trick. Just apply some solder on one pin. You can push on the other pins, they won't get hot, and pop, it just pops into place without burning your fingers. You can push it a bit more. No, that's the final one. A bit crooked, but good for today. And then you can finish soldering the rest of them. It's a bit too much, but yeah, fine. And the power connector. I don't like these big barrel jack connectors because they can get crooked really easily. So if you are going for the aesthetics, you have to manually align them. There you go. And it seems fine for me. Of course, in a regular process, some chemical cleaning will be included after this, but we don't have time for that. But we do have time is to fire up the debugger and load a sample code on our little new guest. And I hope I can finally show it. I already prepared the cube ID for us. And yeah, I know, that's why I'm making a course here. This is frightening first. So with Arduino, you just write your 10s or 20s lines of code, and it works. With STM32, you even have to know how the clock is aligned. Because you can have internal oscillators, external ones, and by routing you can set prescalers. For example, here you can set a much lower clock for to the core. You can set different clock for the peripherals, and all these settings affect the end result. Luckily, this is easy to configure. You just have to know what are you doing, and it's easy to explain, but not today. We will just do the blinky. I tested the UART pins. I always mess up the 2 pins, so luckily this time the transmit and receive pins weren't swapped, so it works fine. But it's a curse for every engineer. You will mess up once in your lifetime. So we have a serial port and port B6 set for general GPIO, and the code is simple. We have a blinky. And why STM32 and professional environments are so frightening? We have a lot of extra what seems complicated, but it's not. Everything is clean code here. Everything says that you are initializing the GPIO less, you are initializing UART1, you are writing to port B pin 6, and you are setting it to 1 or high. You are waiting, not just delay, HAL delay for 500 milliseconds. You write pin to port B pin 6, reset pins clear or 0 or low, and back to 0. So let's give our power, and don't forget to plug it into the USB hub this time. And you can see LEDs are fine. I think I will turn it off now. So let's connect our debugger. These are labeled. It has all the pins that it says that we have the ground, the IO, the clock, and the reset because we need it. And yeah, you are a bit crooked, but it's okay for today. And if you want to launch your code, you just click on the debug. You set up a debug profile. We will set up for fun. We will add a new configuration based on this. Yes, I have a typo in here. What are we going to upload? We are having ELF files as build files. What debugger do you want to use? Yes, I have an ST-Link. I do have a Segger too, but I have an ST-Link here. What port are you connected? JTAG or SWD? What piece are you using? Scan for one, and you find mine. What frequency are you using? Sometimes if you have long cables or noisy environment, you have to step back from 8000 to maybe 140, but let's leave it in auto. You have to specify, but it's already specified what core you have, how do you connect under reset. So you have your reset port here, and we practically haven't really configured anything. Yeah, let's check startup. You can add some extra comments, what you do here, where do you want to start your program, do you want to have a breakpoint at main, so do you want to stop or not, and other stuff. But no, apply and debug. We will compile our code, we connect our debugger, nothing happened, seemingly, but that happened because we have a breakpoint at main, so we start that initialization, and you just press play, literally. So it says resume execution. I will put a breakpoint here. What are breakpoints? That's a really great addition to Arduinos. Yes, uploading code with the bootloader is easy and fun, but debugging is better when you have some problems. So when you let your code run, your code stops at these breakpoints or when an error happens. So I remove this, and we press play, and we have our Blinky example running. And since it's downloaded to the flash, if I stop it, remove the debugger, and power cycle the board, we will have our little program here in the flash, and it still runs. So practically that's all what I wanted to show you today. So if you have any questions left, feel free to ask them now. Otherwise, you can join our Discord server, the Maker Corner. You can ask questions anytime there, so feel free to join. Everyone is welcome here. And yes, I will start an STM32 course on YouTube really soon, and I will explain how to move on from Arduino with these really easy examples, because it's not that hard to move on to professional development, because all this code is generated. Yes, back then I had to write almost all of my drivers manually. Yes, I started with the so-called 80 Mega 8 microcontroller, bare, nothing Arduino, nothing else, just the datasheet and the breadboard and some wires and stuff, but that was literally decades ago. So nowadays, even the professional microcontrollers come with code generation, and you literally just have to click on, I want to have this and this and this functionality. You can add a real-time operating system, you can add middlewares, and almost anything you need. Yes, you may lose some libraries, like written Adafruit libraries for some modules, but that's the professional trade-off. I don't see any questions left. So thank you guys for today, and see you in the next video.